All right, today's our last two quadrilaterals. First, we're going to talk about a trapezoid. Let's first talk about what distinguishes a trapezoid from a quadrilateral. And the main property that makes it a trapezoid is that a trapezoid only has one pair of parallel sides. So these sides are going to be parallel. So basically, a parallelogram has two sets of sides that are parallel. A trapezoid has one pair of sides that are parallel, and then we're going to talk about a kite just in a second that has no pairs of sides parallel. Now, these sides that are parallel in the trapezoid are referred to as the base. Remember, again, base does not mean what it's sitting on. It's just you need to think of the base as the pieces that are actually parallel to one another. There are other parts of the trapezoid that are referred to as the legs. So the non-parallel parts of a trapezoid are the legs. Now we can also have an isosceles trapezoid. So remember, in isosceles triangles, that means that two sides were congruent. So it's going to be very similar here in a trapezoid. If it's isosceles, then we're going to know that the two legs are congruent. So again, the parts don't change, leg, leg, base, base. But now, one of the extra properties, like I just said, is that the legs are congruent. And again, the bases are still parallel. The legs are congruent. Now, when the legs are congruent, a couple of things happen on the inside of the trapezoid. So one thing is that these diagonals now become congruent to one another. They do not cut each other in half, but they're congruent to one another. So this whole entire piece is congruent to this whole entire diagonal. Because you can see that the pieces of the diagonal are not in half. Like one section of the diagonal is a lot longer than the other. Also, just like in an isosceles triangle. So remember when we had isosceles triangle and we had the sides are the same, then we knew that the base angles were also congruent. So that's also going to happen here in your trapezoid, is that these base angles are going to be congruent to one another. And you actually have two pairs of base angles. Because you have two bases, then also these pair of base angles are congruent to one another. So along one base, they're congruent, and then along the other base is separate, they're congruent to one another. Just like we had in some of the other quadrilaterals, we have supplementary angles. Now these angles that are along the legs are supplementary. So remember, again, you're going to ask yourself, one acute, one obtuse, or one of each. And anytime you have one of each, those are going to be the ones that are supplementary. So only along the legs are they supplementary. Along the base, they're congruent. So now let's look at example 1. A shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Find the measure of angle N, L, and M. All right, so if it's isosceles, the base angles are the same. So if that angle is 50, that one's 50. Well, to find L and M, we have to apply that along the legs is 180 degrees. So if we take 180 minus 50, then we're going to get 130. So this angle in here is 130 degrees. And remember, again, along the bases, angles are congruent. So the measure of angle L, 130. Measure of angle M, 130 degrees, and measure of angle N is 50 degrees. All right, midsegment. We've talked about a midsegment before, and we're just going to kind of review it briefly. So the midsegment of a trapezoid, what happens now in a trapezoid is, and it happens in the other ones is too, is that it is parallel to each base. And remember to find the length of it. The length is half the length of the sum of the bases. So what that means is that if I wanted to find the length of this midsegment here, remember a midsegment connects midpoints, If I wanted to find the length of MN, what we would have to do is find the length of AB and add it to the length of CD and then divide it by 2. So you take the sum of the bases, so remember AB plus CD, you add those together, then divide by 2, it's going to give you the length of the midsegment. So we can see that in example 2, we're going to add the bases, divide that by 2, so 25, divide that by 2, that's going to give us the length of the midsegment here. MN is 12.5. In number 3, they gave us the length of the midsegment, and we have to find the base. So think about this setup here, all right? To find the length of the midsegment, they added the 2 bases. So if you add the 2 bases, you divide that by 2, you're going to come out with the midsegment. So you have to undo that. And we've been talking about this. Anytime you're solving and you have a fraction, you have to get rid of the fraction first, so you have to multiply by the denominator in the fraction. You do that so that you can get rid of the fraction. So 21 plus x is equal to 34, and then you just solve. So x is equal to 13. So that's the side of the base. So if they give you the middle, you have to work backwards and solve for x. Okay, now kites. Kites are unique in that no sides are parallel. So when you're looking at their family tree, that's kind of how they separate things based off of how many pairs of sides are parallel. So a kite has no parallel sides. Okay, what it does have is that 2 pairs of consecutive sides are congruent. So again, 2 pairs of consecutive sides are congruent. So remember, consecutive is they're touching. So in a kite, what that looks like is this piece is going to be congruent to this one. So those are consecutive. Now, you have to really kind of just pay attention to what think of a kite that you fly in the air and it's like natural shape. So also, the other pair of consecutive sides are these 2 that are the same length. Now I know consecutive means touching, so these are not congruent. However, it's this pair of consecutive and this pair of consecutive. Alrighty. The next thing that a kite has, it has 1 pair of opposite angles congruent. Now, the angles that are congruent in the kite are the ones that are closest together. Another way to look at it is the angles that are congruent are the ones that are in between the sides that are different lengths. All right, so like here, these angles are congruent to one another. Angle C and angle A are congruent to each other. The last property that a kite has is that the diagonals are perpendicular. So here, the diagonal BD is going to be perpendicular to diagonal AC. And again, remember, anytime we tell you something is perpendicular, now you have right triangles are actually being formed inside of a kite. So always be prepared to use your right triangle. Let's look at example 4. Find the measure of angle G in the kite shown below. So we need this angle here. Well, every quadrilateral on the inside is 360 degrees. So this whole interior of all these quadrilaterals we've been focusing on is 360. Because if you do n minus 2 times 180, that's where that 360 comes from. So quadrilaterals are special in that the interior is 360 and the exterior is 360. So if we have 360 degrees, we take out 85 and we take out 75, right? That's going to leave us with 200. Well, 200 degrees is actually for both of these angles. So, how can we find just G? Well, remember the property of the kite is that these opposite angles right here are congruent to one another. So if they're congruent, I can divide the measurement left to get just one, and that's why the measure of angle G is 100 degrees.